Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Rolf Klingberg, your host. Today you see me holding what I call the wingtip panel of my Klingberg Wing Mark II. It's about the last 6 feet of the wingspan. And I'm holding this here today because I want to talk about lightweighting this panel. I'm building 2 new ones. And I wanted to clarify some terms that I use so there's no confusion. I call this the wingtip panel. But you'll hear me refer to wingtip at this part out here. After the last rib, this unit that glues on the end, I call this the wingtip. So not to confuse the two. Wingtip panel, wingtip. This particular wingtip here is a composite one. The other wing has a balsa tip. Okay, I'm back. What I'm doing currently is building 2 new wingtip panels because the original ones have been through so many modifications. I'm not certain that they're flight worthy anymore. And we're getting ready to get into some more heavy duty flight testing. Hopefully we're going to get into some higher altitude flight tests a little later this year. So in the process of building new ones, I'm trying to find ways to lighten the weight. If you've been following with, you know that I added these trailing edge elevons. They added about 4 pounds to the glider and shifted the CG aft, which we don't like. So I'm trying to take some weight out of the wingtip panels, which are even further aft than those new elevons, to help move the CG back forward and reduce the overall weight of the glider, which is always a good idea. So the goal here is lighter weight wingtip panels. I want that whole panel to be lighter weight. Now that panel that I was just showing you weighs about 5.5 pounds, give or take a little. The 2 wingtip panels have 2 different wing tips on them. One is all balsa and plywood, and then the one I just showed you is composite. And they have 2 different spar construction methods. And strangely enough, both wingtip panels turned out to be the same weight, because the one with the heavier spar construction has the lighter weight composite wingtip, and the one with the heavier balsa and plywood wingtip has a lighter weight spar construction method. So I'm going to try to combine those 2 into one design that is lighter weight and do some other changes. So the lighter weight wingtip panels, and the goal is to save 4 pounds, and it's probably not possible because we're talking about 11 pounds total for the 2 wingtip panels. So to pull 4 pounds, which is the weight of the new elevons, out of the wingtip panels, probably next to impossible. I suspect at a later day I'm going to have to go back and look at the new elevon design and build another set yet of those, and maybe get rid of the carbon fiber and substitute Kevlar with some unidirectional carbon fiber in it, maybe, I don't know. But 4 pounds for those elevons, a little heavy. So here's my plan for reducing the weight of the wingtip panels. I'm going to use half the number of ribs. The ribs that I had in there, too many, not really needed for aerodynamics, and they have a fair amount of weight to them. So cut the number of ribs in half. That's an easy change. Just simply don't put them in. Kevlar D-tubes. Here's a bad version of the D-tube that goes in the wingtip panel, and I'm going to work on lightweighting these. The old ones had carbon fiber on the inside and 1 layer of 120 fiberglass on the outside, and some unidirectional carbon fiber for toughness on the leading edge. So this one weighs 17.69 ounces. So just shy of 18 ounces, a little over a pound. And I'm going to try to take some of the weight out of that. I don't know if I'm going to be successful, but we're going to give it a go. And I'm going to do that by using the Swift construction method, 2 layers of 120 Kevlar on the outside, 1 layer of 120 Kevlar on the inside. And the 2 layers on the outside are for toughness, so I won't need the unidirectional carbon fiber at the leading edge there. I'll be able to eliminate that. That'll save a little bit of weight. 2 layers of Kevlar, about the same weight as the 1 layer of fiberglass. And on the inside I had 4 ounce carbon fiber, and that'll be substituted with 2 ounce, 1.8 ounce Kevlar. So that'll be a little bit lighter. But you'll see in a moment that I'm going to have to add back in some unidirectional carbon fiber. So I might save a little bit of weight here on the D-tubes. If I'm lucky, maybe 4 ounces out of the D-tube, out of each one, so that'd be 1/2 pound total. molded spar. I'm already in process. I've built both of these. We're going to talk about it in detail here in a moment. At this point here, I've saved about 3/4 of a pound for the molded spar design from the previous design. So if I save half a pound here, 3/4 here, oh, well, we're over a pound. Half the ribs, oh, that might save another 4 ounces. So we're getting there, getting closer to 2 pounds. Composite root core. That's a part of this, the molded spar here, and it's part of what saves the weight. And I'm going to talk about that in detail. A painted D-tube. You know, the D-tubes are currently covered with the Oracal 651 stick-on vinyl, which is really nice and easy to work with and gives a great finish, really smooth, UV resistant. However, it's a little heavier than paint by a skosh, a few ounces. So I'll paint the D-tubes instead of putting the Oracal on there, and that'll save a little bit of weight. I'm going to make both wingtips composite. I'm going to cut the one wingtip off of this other one. No, I still have the molds. Maybe I'll make new ones. I'll make new composite wingtip on the one side out of Kevlar because I have the molds for that. I have the molds for the left wing. I don't have any molds for the right wing. On the right wing, will I take time to make a mold? I don't know. I might just make it a 1 pound per cubic foot styrofoam core and lay some Kevlar over that. But I should be able to save a little bit of weight here on the tips. Maybe getting rid of the one balsa one, going to Kevlar. Maybe I'll save 6 to 8 ounces on that. Composite trailing edge. They're currently basswood, and they're spliced to get the long length. So there's a little bit of weight in that, and composite trailing edges will be lighter. How much, I don't know, maybe a couple of ounces out of the trailing edges. And composite root sheeting. The root area is sheeted to help carry some of the loads and provide a strong attachment point for the fabric covering. It's currently basswood. If I go to composite, yeah, it's a lot more expensive, but it will be lighter weight. It might save a couple of ounces there. So all told, maybe 2.5 pounds, 3 pounds is probably more realistic than my goal of 4 pounds. But we're going to give it the best shot. If I get half of the weight of the elevons out of the wingtip panels, that'll go a long ways to moving that CG back forward. And probably have a more durable wingtip panel because I'll be eliminating most, if not all, of the wood. I think the cap strips on the ribs are still going to be wood. I think I'm going to have basswood for the cap strips on the ribs, just because it's really the best solution overall. And as long as it stays covered and doesn't get wet, the wood will be fine. So that's the goal. And the design of the spar and the D-tube is changed. D-tube's the same, what I just showed you, the bad sample there. But the spar itself is one layer of foam. What is it, 2 mil, something like that. 2 plus a little, 3/32 of an inch. And Kevlar on either side, and then it's molded with a couple of flanges on it. And I'm going to be adding some carbon fiber to the D-tube. So let me show you one of the new spars here. Let's see. The previous design, these are spars that I made for the rebuild. And these are a little heavy. This weighs a pound. And I thought that was quite heavy for spars. Arex foam core here, 3/32 of an inch, with 120 Kevlar on either side. And it was made up as a flat sheet and cut to shape. And then I glued on wood cap strips and then applied pull-truded carbon fiber to carry the bending loads. And then at the root, I have some 1/2 inch thick plywood in here and a beefy carbon fiber root fitting here that's bonded onto that, and then it has a layer over it to help keep it bonded in place. A lot of this was overkill. I discussed that before. I don't really need this plywood because I have no mechanical fasteners through here, so I don't have to worry about tear out. So I can lightweight that core. And the wood cap strips with the pull-truded carbon fiber cap strips are secondary bonding operations, which add significant amount of weight for the epoxy that's used to bond these on. The reason I did it this way is because it's quick and easy. You make a large sheet of this material for shear webs, you cut out shear webs, and then you build up, very much in the manner of a model airplane, you build up a spar out of this. But it's not the lightest weight solution because of the secondary bonding. The wood's heavier than it needs to be, and there's some other savings that I can get out of this. So let me show you the new spars. Here's one of the new ones. Now, this thing right here is, I molded this on a mold that I made out of the highest density MDF stuff that I could find at Home Depot. I'll put up a little picture here of what that mold looks like. It's basically just a tapered piece of wood. The edges are rounded off. And I put down a layer of Kevlar, 120 Kevlar over that mold. Well, actually I put on packing tape on the mold first so it doesn't stick. Put some PVA on that, and then laid down one layer of 120 Kevlar laid up on the bias, so it can help take some bending loads so the fibers are running this way and this way. And then put on the layer of foam on top, the 3/32 inch Airex foam, and then put another layer of carbon fiber over the outside, molded that. And as I speak along here, you've probably seen the pictures go up of that process. Now, that came out really, really lightweight. Without any of the root fitting stuff in here, this weighed 3 ounces. So very light, less than a quarter pound. But then I have to add to the root end to accommodate the fitting that goes on here. So what I did is, I'll put up a picture of it here. There's a foam core in here. There's a 5 pound per cubic foot urethane foam core, a little bit of Airex to increase the thickness for putting on the root attachment fitting. And then to distribute the loads out, I put 6-ounce carbon fiber here on the inside and on the outside and wrapped those around on the flanges. Okay, so I wish I would have had some 4-ounce carbon fiber. It's really all that's needed, so this is a little bit of overkill, but it works. Let me turn around here. Okay, I'm back. Here's the root fitting. I managed to salvage this off the other one of those, and it will slide on here and bond in place. And then there'll be a layer of carbon fiber that comes over on this side and on this side. So essentially, we're looking at carbon fiber on either side of these flanges here. So they're gripping it like this and distributing that load out into the shear web and the spar caps. And that's what's going to hold this fitting on. Now, I could make this fitting lighter. This fitting was a little overkill, but these are labor intensive. It'll take me a week of fiddling around to make new ones and cut them to fit the main wing panels. And these already fit. They're a little bit heavier. I might be able to save an ounce or two, but I'm going to have to just let that one go, and I'm going to reuse these fittings. So with that fitting bonded on here, this will weigh about 6 ounces less than this design right here. Now, this was not the design that's in the current wing. The design that's in the current wing is even heavier than this. But I know I'm going to save at least 6 ounces per side, 3/4 of a pound total, maybe a little bit more. And I'm simplifying the attachment of the rib cap strips. You'll see that this is a C channel, and this is going to sit in the D-tube. If I can get the D-tube over here, if we can see this. It's going to sit in the D-tube like this, with the flanges facing aft, and it'll go in just about like that. So there's about this much flange sticking out of the D-tube. And that amount of flange is where the rib cap strips are going to attach. So that's how this will mount in here. So the spar itself will be bonded to the inside of the D-tube along this line. And that should work out just fine. Now, as a part of this process, I talked about margin on margin and overbuilding and all of that. So I gave second thought to the pull-truded carbon fiber cap strips that are on the spar that run here. We see them here on the previous design. Now, it was designed such that those cap strips would carry all the bending loads, ignoring the fact that the D-tube itself could carry bending loads also. So I decided to refine the design and not overbuild. So I included the load-bearing capability in terms of bending of the Kevlar D-tube, and then I need to add back in enough carbon fiber to carry the remaining loads. So remove those pull-truded cap strips. You'll see they're not on here. I got a little bit of carbon fiber at the root end, but for the most part not here. Then I have to add back in enough unidirectional carbon fiber to carry the loads. Now I could put 1/2 inch wide strips on here, 3/4 inch wide strips on here, and that would be a secondary bonding operation, gooey, messy, difficult to do. No, we're not going to do that. So I'm going to beef up the D-tubes, increase their strength to carry those bending loads. And in order to make up the difference between the Kevlar and the carbon fiber cap strips, I have to add in this much carbon fiber. Here's a piece of it, like this. And at the root end, about 8 inches wide, at the tip it's 0. And I'm going to mold this right into the D-tube on the inner surface in here. So instead of being a secondary bonding operation, this will be a part of the layup of the D-tube and use the same resin. So that'll save some weight. So it's literally going to go top and bottom inside the D-tube. Get off the end. It'll go inside the D-tube like this. I hope this stuff is coming in frame. And it'll go in here like this. And that'll be molded the same time the D-tube is molded. And it's tapered like that because it's the loads decrease as you go out to the tip until they're essentially 0. So there's one of these on the bottom, one on the top, and then the D-tube will be strong enough to carry all the bending loads. That should, in theory, save me some weight. We hope. Anyway, so that's the plan for the new wingtips, and we'll see how it goes. So far, I've saved 3/4 of a pound. I'm going to be molding the D-tubes next week. I hope to finish up the spars this weekend. Next week, mold the D-tubes, and we'll find out what they weigh. So we'll have the weight of the spars and the weight of the D-tubes, and I know the weight of the ribs with cap strips, so I'll be able to give you a finer cut on how much weight I'm going to save. Cross your fingers. Save some weight. And in theory, at the end, it'll come out to be just as strong as the original wingtips. So in terms of lightweighting and aircraft design, if I saved even 2 pounds out of the 11, that would be considered a significant achievement. Usually you lightweight, you save 10%, 15% if you're good at it, if you've got some margin to work with. But because of how I designed it originally so conservatively, there's enough margin to work with to get a significant amount of weight out of it. So there we go. The one note that I should have to tell you, help you with your own projects, the mold that I showed you for the spar, I did not like that solution. I had a difficult time when I vacuum bagged this, put the vacuum bag over the top and went around this curve. As the vacuum bag came in this way and squished down on top, it pinched these corners up and would cause buckles. And I had to go back in and work the vacuum bag and push it down and smooth it out, and what a pain in the butt. And that's probably because it's a male mold. If I would have fought for 10 seconds longer, I could have routed out a mold, a female mold, in 2 sheets of the MDF and a nice female mold where this would be a non-issue because it'd be pushing down into the mold and out. And on the inside, it'd be really easy to smooth out the vacuum bag just by going with my finger or a popsicle stick or something like that. So for this part, female mold probably superior. Anyway, I hope you've enjoyed this information. Please stick with me. I greatly appreciate your continued support, and I think we're getting close to some major flights. Keep your fingers crossed. And as I always say, fly safe. Bye for now.